it's working well?
Yeah. Yeah, I have tried. Let me just try share my entire screen.
Sure.
Yeah, correct. Can you see my screen?
I can see your screen.
Yeah,
Well, I
that's not
think
my presentation.
but I'm seeing your browser screen rather than your presentation.
Correct.
Okay.
That's correct.
Okay. All right. I guess all presenters, I believe, are here now. And yeah, it's 8 p.m. Mountain Time, which means that session. So welcome everyone to a new and exciting session for ICSE this year, 2022, in our virtual program. In this session, we have 4 exciting papers from various different tracks in ICSE. We have 1 paper from the NEAR track, we have 1 paper from the Software Engineering and Society track, and 2 papers and presentations from the technical track. And the first paper that we have from the NEAR track, Francois Gauthier, is going to present runtime prevention and deserialization attacks. Francois, if you want to share your screen.
That should be on now. Okay. Yeah, so this presentation is about runtime prevention of deserialization attacks. This is joint work with my colleague, Saurabh Bey. So I realized that serialization is not a very well known, so let me explain what this is all about. Basically, anytime you have an object graph in memory that you want to turn into a persistent format, it can be JSON, it can be XML, or if you're using Java native serialization, it would be a byte stream. You are doing serialization. And if you do the opposite, well, then it's deserialization. So turning back the persistent format into an object graph in memory. The issue with serialization and deserialization is that if an attacker controls the serialized format of an object graph, he or she can, to a certain extent, control the code that is going to be executed while the serialization is happening. And this has been proven to remote code execution attacks, which is extremely critical in different languages like Python, Ruby, .NET, and so on and so forth in different formats. But today I'm going to focus on the Java serialization format. So if we look at the top of the slide, we have a very graph with just a timer task and a field that points to a common task. And this object graph, it will look something like the bottom of the slide. So the stream will contain the class name, the field description, and then the value, which is another class, and so on and so forth. And so upon deserializing this, if it's maliciously crafted, it can lead to remote code execution. So the hypothesis we have in this work is of classes and their features, they will differ significantly between benign and malicious. So what we did in this work to verify this hypothesis is to look at a repository of known deserialization attacks that is called YSOSerial. You can find it on GitHub. And we extracted 8 Boolean features that seem to capture crafted malicious deserialization chains. I won't go through the whole list. It's all in the paper. And so then the idea is that after we can abstract a class to vector of 8 Boolean feature, we use those Boolean vectors, or the space of Boolean vectors, as states in a Markov chain. And so then we can model deserialization as just transitions in the Markov. Basically have transition from the feature set that represents the first class in the serialized stream to the second one, the third one, and so on and so forth. And so by doing this kind of abstraction to a Boolean vector and looking at the transition between different states, we can model the whole process of deserialization as a Markov chain. So what we did in this study is to basically build 2 different Markov chains, one for benign deserialization chains and one for malicious deserialization chains. The system we use for benign chains is WebLogic Server. That's from Oracle, and it uses a lot of this visualization for its operations. And we use WISO Serial to a malicious Markov chain. So then at runtime, what we are doing is basically, as we are reading classes from a serialized stream and reconstructing the object graph, we are measuring the probability that the stream was emitted by the malicious Markov chain and the benign Markov chain. And so then it's really just a matter of taking the highest probability between the two to label whether or not the stream we are currently visualizing is malicious or not. And we did this using two different approaches to train our Markov model. The first one at the top is using Bayesian inference. So this is using probabilistic programming. The second one is the very classical empirical approach where you estimate the transition probabilities based on your data set. As you can see, the precision is, if we're using Bayesian inference, around 20% better, but the training time is also much, much, much higher. The t parameter here is really just the width of our confidence interval. This is for our prediction. So the higher the t, the larger the confidence interval, and the more conservative we are, which is why we have a slight drop in precision, but an increase in recall. The rest of the details are in the paper. Thank you for your attention, and feel free to send me an email if you have any questions or ask them here today. Thank you.
I'll be clapping along with the alarm bell just to add to the ambience here of the talk. Thanks, Francois. So one thing that I failed to mention at the beginning of our session is that the way we're going to conduct the session, we're going to go through all the presentations first, speaker after speaker, and then after that, we're going to have our Q&A session for all presentations, including the audience and including any questions the speakers may want to ask each other or the audience would like to ask and address to the speakers directly. So thanks again, Francois, for your talk. And now we're moving on to our second talk of the session, DressML, a domain-specific language for modeling exceptional scenarios and adaptive behaviors for drone-based applications from the Software Engineering and Society. And Paul here will be presenting this talk.
Okay, hi everyone. My name is Paulo Henrique Maia from the State University of Ceará, and the paper is called DressML, Domain-Specific Language for Modeling Exceptional Scenarios and Self-Adaptive Behaviors for Drone-Based Applications. Although drones have been initially created for military purposes, drones have been currently used in several civil applications, such as protection of agricultural products, search and rescue, and delivery and monitoring of goods. Drones can either be operated manually, in which a human pilots the drone during the flight, or automatically, in the case that the drone has a predefined path that it will follow during the flight autonomously. But there are some uncertainties that can happen during the flight, and they are very difficult to predict at design time. And those uncertainties may generate exceptional situations. So to deal with those situations, one can either create customized drones, but they are very costly, time-consuming, and very difficult to reuse in other situations. So it is, in fact, very impractical. Or hence, drones with self-adaptive capabilities. So the drones can monitor their internal state, their environment, and adapt themselves in if necessary. There are some approaches that deal with self-adaptive drones. So the technical ones deal with quality requirements and privacy, architecture, or behavioral adaptation, but all of them need technical skills. On the other hand, if you're trying to specify exceptional scenarios, even using generic modeling notations like UML diagrams or MSCs, or using a drone-based scenario modeling notations, the current work have severe model restricted scenarios. So it's very difficult to model different scenarios considering the current state of the art. So to tackle that, we proposed the which is a domain-specific language for to model drone exceptional scenarios and self-adaptive behaviors that provide a high-level abstraction of the main available drone resources and environment variables. This benefits the modeler by reducing the complexity of specifying both the exceptional scenarios and the corresponding behavior adaptation strategies, and by enabling the modeling of more possible situations. The DSL syntax is built upon concepts from the behavior-driven development, which allows the specification of exceptional scenarios by using the very well-known given-when-then structure, and the aspect-oriented programming, which allows the representation of the drone main features as join points and adaptation strategies as before, after, and around advice clauses. The DRASML can also be used with a model-to-text transformation engine, so one can generate a specific code for a specific drone platform or simulation. Our language has been built upon some specific concepts regarding the drone internal states, flight operations, sensors, actuators, and mission. And here you can see an example of exception scenario model using our language. It is divided in 4 main parts. The first one says the name of the exceptional scenario. In this case, it is keep flying, which indicates that the drone should keep flying. The given clause declares the state of the word, so it regards drone internal states and environment conditions. So in this case, if the drone from the destination is less than 2 kilometers and the wind speed is higher than 5 meters per second, and in the direction is east, the when clause is, defines the predefined behavior. In this case, the drone should do a safe landing procedure, and then clause is when the modeler creates the self-adaptive behavior for that exceptional situation. In this case here, it is an around for the predefined behavior, and that goal destination is the new behavior that the drone has to execute. So we evaluated our approach with a proof of concept for monitoring a forest to search for fire spots. We used a drone simulator called Dragonfly to represent the exceptional scenarios. And we have shown that our approach is valid and may be helpful to specify exceptional scenarios for other drone-based applications. We have something that we want to do in the future, and we are open for questions. Thank you very much for your attention.
Thank you. Thank you so much, Paul. Oh, there are the claps going and the applause going around here in the chat. Thank you so much. So yes, same deal with the questions. Keep all your questions until the end of all the talks, and then we're going to open the floor for questions from the audience or between the speakers as well. Hey, Michael, you can ask the audience can ask you, everything goes here. So for our third talk of the session, now we're moving on to the technical track, and for this talk we have Shufei, who is going to be speaking about learning and programming challenges of Rust. Ooh, interesting. A mixed method study.
Yeah, can you hear me and see my screen sharing?
Yep, it's all good.
Okay. Great. Hello, everyone. I'm Shufei Zhu. I will present my paper, Learning and Programming Challenges of Rust, a mixed method study. So this is a joint work with authors from Penn State, Wisconsin, and China Telecom Cloud Computing. So Rust is a young programming language designed to provide both low-level efficiency and high-level memory safety and thread safety. Rust conducts strict compiler checks to achieve this purpose. Rust's popularity is increasing dramatically these years. According to Stack Overflow surveys, Rust has been the most loved programming language since 2016. Rust has been adopted to build many safety-critical software systems, such as OSs, browsers, and blockchain systems. Rust safety mechanism centers around two important concepts: ownership and lifetime. The basic rule only allows value to have one and only one owner. The value is dropped when its owner's lifetime ends. To improve the flexibility of coding in Rust, Rust extends its basic rule to have multiple extended rules. For example, Rust allows to temporarily borrow a variable's ownership using a reference. A reference can be immutable for read-only accesses or mutable for so in this example shows Rust only allowing immutable references. It also allows multiple Rust allows multiple immutable references to variable to exist at the same time. But it only permits at most one immutable reference at a time. So here we see in this example, there's only one. There are multiple immutable references on the left, and there are only one mutable references on the right. All the rules are checked statically during compilation, and they essentially prohibit having mutability and aliasing at the same time. They together can prevent many severe memory bugs and concurrency bugs. So unfortunately, Rust is known to have a steep learning curve, and it's difficult to program in practice. We can see there are a lot of complaints from the internet that Rust is too hard to learn. So there are two possible reasons. First, Rust safety mechanism is very unique. It is very difficult for programmers to migrate their previous knowledge about programming experience. And second, the design philosophy of Rust is to reject all the suspicious code. And Rust safety checks are strict, sometimes overly so, making Rust code hard to be compiled. So let's take a look at a real-world example where Rust safety rules confuse programmers. So here, variable out1 and out2 are similar to each other, since both of them contain two full objects. However, out1 is an array, but out2 is a tuple. So function test takes two full objects as inputs. It uses a mutable reference to borrow the first full object and an immutable reference to borrow the second one. And function test is called here using the two full objects in the array as inputs, but the Rust compiler reports an error on this line. The reason that the elements of an array must be borrowed altogether in Rust, since the Rust compiler conservatively assumes an index can access any elements in an array. And out1 has already been mutably borrowed at the first parameter. Thus, it cannot be borrowed again at the second parameter. The second function call uses the two full objects in the tuple as inputs. But surprisingly, this call is allowed by the Rust compiler. This is because different tuple fields are borrowed separately in Rust. This example demonstrates that the complexity of applying Rust safety rules. Besides the safety rule that a mutable reference cannot coexist with another reference to the same object, programmers must also know that how a rank tuple elements are borrowed together. Without a clear understanding of these, it is very easy for programmers to make similar mistakes and write programs rejected by the Rust compiler. To systematically understand the program difficulties of Rust, we conduct an empirical study on Rust-related Stack Overflow questions. We focus on questions related to safety rule violations. So to conduct this study, we first build a taxonomy for the root causes of the violations. We then apply two statistical models to pinpoint when the safety rule is more confusing. Finally, we inspect whether the Rust compiler provides all necessary information for programmers to comprehend the violations. We got 6 findings from the empirical study. And to validate the findings of the empirical study, we conduct an online survey on Qualtrics. Besides directly asking participants for their previous experience in coding Rust, We also show them small programs containing safety rule violations and design questions to observe how participants comprehend these violations. In total, we received 101 valid responses from real-world Rust programmers. We conduct extensive data analysis on the response to check whether they are consistent with the findings in the empirical study. We observe that Rust safety rules are difficult to apply in concrete coding scenarios. Sometimes error messages provided by the Rust compiler may not be helpful enough. In total, we have 6 findings about the programming challenges caused by Rust safety rules. Those findings can be useful for Rust learners and programmers. And moreover, these findings are confirmed by the online survey with statistical confidence. So here's the findings from our empirical study and how we evaluated them in the online survey. And welcome to give questions. Thank you.
Thank you very much. Thanks, Xufei. And now, so it's you, Francois, who's sending all those applauses, right?
Yeah, if you look at the bottom, there's emoji,
Yeah,
and you can send
and
applause.
I see the name floating around, but I keep following where the name's coming from. But I quote you this time. Oh, there we go. See how now. All right. Thank you again, Xufei, for the talk. And now moving on to the last talk of our session today, Michael Koblin's going to talk about another Rust paper. This time it's about garbage collection and how to make Rust easier to use. Michael, the floor is yours. You're muted. Famous words in any virtual session and conference.
Okay,
there we go. Yes, I can hear you now.
I'm trying to share my. Oh no. Okay, I think I have a mid-space malfunction. Hold on a minute.
Okay, that's okay. Take your time.
Temporarily. Okay. How about now? Yes. Okay. There. Got it. Okay. Sorry, there are. Okay. Okay. Thank you very much. I'm very excited to talk to you about this work. So we just learned a lot about Rust. As you may know, in contrast to Rust, C and C++ allow dereferencing arbitrary pointers. As we know from prior work, a lot of the severe security bugs have been due to memory safety problems. So that's one of the big motivations for a language like Rust. Rust is memory safe, and it uses the ownership mechanism that we just learned about to provide this memory safety. And in particular, it avoids the runtime cost of garbage collection. Our work is rooted in other empirical work that showed kind of similar things that we just learned about, namely that Rust is harder to learn than other languages, and that a lot of people feel like some of the biggest challenges are ownership and borrowing. So our idea is to mitigate the usability cost of ownership by adding a garbage collector to Rust. And the observation is that most code in most programs is not actually performance critical. And so the engineering approach that we're proposing is gradual adoption of ownership. That is, the default should be used to use garbage collection. So most code is not performance critical. We can use garbage collection for that code. And then as we discover performance critical code, we can use garbage collection. We can avoid using garbage collection for that code. So how do garbage collectors work? Well, they trace the heap to find live objects, starting at what are called roots. So what we did is we modified the Rust compiler to emit LLVM stack maps. This enables the runtime of our prototype to find roots automatically for the cases that are implemented in the prototype. So we built this garbage collector, and then the question is, well, does it help, right? So we did a randomized controlled trial with 333 participants from a programming languages class. We gave 4 lectures on Rust. We gave 2 live coding demos. And then we asked students to answer some questions after each task to learn about their experiences with the task. So here's kind of the structure of the experiment. First, everybody did this basics task to familiarize themselves with kind of the basic syntax of Rust. And there was no garbage collector used there. It was just kind of basic traditional Rust. And then there were 2 tasks, one about ownership and lifetimes and one that involved alias to mutable data. So this was a situation where you had multiple references to mutable data. And if you're using traditional Rust, then you need to use something called interior mutability in order to manage the multiple mutable references to the same objects. On the other hand, if you're using a garbage collector, then the garbage collector takes care of that problem. So you can see if you're in the traditional case, after doing the basics task, you do this ownership task and then the aliasing task, all without the garbage collector. If you're assigned to the bronze condition, you'll do the basics task and then the ownership task and the aliasing task with the garbage collector. And then we take away the garbage collector and ask people to redo the task without the garbage collector. This is to make sure that the learning outcomes are comparable across the two conditions. All right, so what do we find? There's no significant difference in completion rates of the ownership task, but the bronze users were more than twice as likely to score 100% on the aliasing task. So it seems to really help with that task. Likewise, if we look at times, the bronze users finished the aliasing task significantly faster by about a factor of 3, 4 hours versus 12 hours. You can also see some of the non-bronze users, the people who use traditional Rust, spent a really long time on this task, up to 70 hours that people reported spending. So you can see that the distribution is very wide there. We asked them to what extent they agreed with the statement that garbage collection in Rust makes writing programs easier. We asked this question after each part of this study. And participants were more likely to think garbage collection was helpful after doing the assignment than before it. Now, initially, about a third of the people thought it would be helpful. That's the green and yellow section there. And then after doing the challenging aliasing task, almost everybody agreed that garbage collection made programming easier. But what really convinced them was when we took the garbage collector away, and then they had to redo the task without garbage collection. You can see the size of the yellow bar, the strongly agree bar, is much larger there. So that's kind of a neat result. We asked the participants how much they liked Rust. We saw no significant difference between conditions. This we thought was surprising, right? You might expect that if you save people time, they might like the language better. Turns out not. So then you might ask, well, what should we do if we want people to actually like the language better? So we looked at correlations between how much they reported liking Rust and other factors, like how much time they felt they spent compared to how long they expected to spend, and how challenging they thought the assignment was, and how frustrated they were, and how stressed they were. And you can see there's a stronger correlation between liking Rust and how stressed they were than between liking Rust and how they felt about how much time they spent. So maybe if we want people to adopt programming languages in the future, we should focus on reducing programmer stress rather than only reducing the amount of time they spend. We asked them what was most difficult. They said things like coding with ownership rules and trying to implement mutability in general was just such a headache. It was like someone who combined the worst parts of C and Java. And you can see why, right? The interior mutability approach requires that in the API, you either manage reference content pointers or use a dynamic borrowing mechanism. Whereas if you use these garbage collected references, they would just kind of work. We did a follow-up study to try to understand what we might do next to help students be more successful with Rust. We observed some key opportunities. One is that low-level error messages in Rust don't teach high-level concepts, right? So if you say insert ampersand right here, that doesn't really teach people about borrowing. And so when people get into a problem that they can't fix by inserting ampersand, they're not sure how to do it. In general, I think we don't do a good job of teaching debugging, but really fixing compiler errors is kind of like debugging. So I think we need to figure out how to teach that more effectively. Some students got really confused when they saw only a partial list of errors rather than kind of the whole story. Because an error up at the top of the program can kind of result in bogus errors or lack of errors down below. And then at some point, students really need to switch from kind of cargo culting answers from Stack Overflow and really understanding what's going on. Maybe we could try to do a better job helping students make that transition. In conclusion, garbage collection significantly reduces the architectural burden of ownership in Rust and can enable completion of complex tasks in less time in ownership-based languages like Rust. So thank you very much, and I look forward to the discussion.
And thanks to all our other speakers in this session. That would be the last talk of our session, and that means that we can start our Q&A for the session. So just a quick reminder for those of you who just joined us, the way we're going to do the questions, basically anybody can ask anybody else a question, audience, speakers, everything goes. If you want to ask a question, you can just unmute yourself and ask. If you prefer to write it in the chat, you can do that as well. Just I would ask you, if you do so, please add the name of the speaker as a prefix to your question so that we know who the question is directed to. And I'll read the question from the chat as I'm following it. And I believe there's already a question in the chat, so let's get that as a starting point of our discussion. So that question is from Francois to Shufei. Apart from providing better error messages, do you think it would be helpful to develop a set of Rust best practices to avoid the pitfalls that you highlighted in the first place?
Yeah, I think that would help. From our small data set where we collected 100 code snippets from Stack Overflow, we identified many concrete usage scenarios where you would find using the Rust CVE rule with a concrete code with a concrete coded construct becomes difficult. I think these answers of these questions provides kind of the best practices of Rust, and if we can put those best practices into a tutorial, that would be really helpful. Personally, I actually learned a lot of these kind of best practices from these questions, and that was also really helpful for my Rust programming experience. I think that's my answer.
Thank you.
Right. One more, actually, now from Michael this time. I'd love if you could talk more about the specific challenges that you found and how you validated each one on Stack Overflow.
Yeah, so we identified some, for example, we identified some concrete usages of Rust CVE rules. For example, when you write programs that involves multiple functions shares a lifetime tag, you would find it difficult to use with your self-defined lifetime tags. And we have that belongs to our one of our finding in the paper. We also have some other findings as compiler error messages may not be helpful, and lifetime computations are more difficult. And we validate these findings through the survey. Did I answer your question?
I guess I was wondering, when you say you validated through the survey, what did you ask, and how did you conclude that validated your challenge that you were addressing?
Probably let me share my screen and showing the table in my presentation.
I guess what I'm getting at is, if you ask, do you agree that X is a challenge, and people say yes, it's not clear what that really means. There could be 100 challenges, and that one is, the bottom one, and it's not very important, but people agree it's a challenge.
Did you mean we have like 100 questions, 100 code examples?
No, I just mean, wait, when you said, I didn't quite understand what you did with Stack Overflow. So you looked at 100 questions, and you looked.
Yes.
Right. Yeah. So, but then you did. So you came up with a hypothesized list of challenges, right? And then you asked people in a survey about those challenges. What did you ask them?
We first observed the 100 questions and have like 6 findings from these questions. Let me show you these findings. So let me. So we have the 6 findings over here, and so we observed these 6 findings from the 100 questions, and for most of the findings, we designed, or like we have some similar observations from the online survey, and therefore we validated these findings from the empirical study, which means the observations from the Stack Overflow questions.
Oh, I see. So you did a survey and you asked people what they thought was hard about Rust, and they listed a bunch of things, and you analyzed that list.
So in the survey, we provide with some like programs and ask them questions about these programs. For example, we have we show them 2 programs and ask them questions to highlight tokens in the program that they believe these tokens causes errors. And from the results of this question, we find that a program containing a borrow rule violation has a larger score than a program containing a move rule violation. So in this case, we know that borrowing rule is more difficult than move rule, which confirms our findings, which confirms our finding 5.
Interesting. Okay. So I'll have to go read the paper if I want to understand the details then. Okay. Thank you.
Thank you.
Thank you. So moving on to our next question. This one is from Fabio to Michael. Did you receive some feedback or comments of your work from the Rust community?
Yeah, so it's been interesting actually. So the initial discussion was about an early version of Bronze, which is the version we used in the study. And in that version, we didn't have the dynamic checking yet. So in the final version, if you want to obtain a reference to a garbage collected object, you need a borrow operation. That version was not in the study, and the result was that it could be you could exploit that to use it unsafely. So a lot of the comments that we got online were basically like, "How dare you," which was kind of interesting to watch. But we made that change, and it's I think the issue is there's a belief in the community that if you add garbage collection, what you have is not Rust anymore. And I don't agree, but I think it's kind of a social challenge. So on the one hand, it's clearly beneficial for people to add garbage collection, and there's other empirical work showing that you can use garbage collection in a limited way with pretty limited performance impact. But I think there's a separate social question, and I don't have a good answer to that one.
So I kind of have that, Michael. Like, is the main concern for not adding garbage collection performance impact, or are there any other concerns from the Rust community?
Well, the initial discussion. I mean, presumably, maybe you're alluding to a form you read or something. Maybe you want to say, Fabio, what you're referring to. But the initial concern was, hey, this is unsafe, and the answer is okay. That yes, we okay, but we can make it safe, and we did. So then the second question is, is this really still Rust? And that's kind of the social issue that I was alluding to. So like the first issue, we fixed. The second issue, I think, is harder.
Right. Yeah. Okay. All right. Our next question goes back again to Shufei from Shihao. How to improve the error messages, and is more UI element involvement helpful?
We actually show them a web page, which is a survey. In the survey, we have a figure, which is like a screenshot of a Rust error message. And we insert one piece of text, which is our enhanced error message. Let me just show you. Yeah, so on the right, you can see there are a note out1 is an array, and note array out1 is array can be borrowed as a whole, which is the text we inserted manually. We didn't actually implement an UI. We just add some text in the error message. Yeah. That's my answer.
All right. Okay. Another question that we have this time from Fabio to Paulo. And the question is, could we adapt your DSL approach for robotics, for example? So something outside of drones.
Yes, thank you for the question, Fabio. I think so. In fact, we can reuse our main idea, which is using the BDD clauses and the AOP concepts to model exceptional scenarios for different domains. We are to adapt this approach for IoT, the IoT domain. So I think for robotic, it would be closer for IoT, and they can even share some of the domain concepts. So I think so.
All right, and I think this is a good segue to the next question, also Paulo, related to the same topic. This question is from Francois, and the question is, your given when then templates remind me a bit of the if this then that framework that's used in IoT automation. So can you explain the differences maybe perhaps between your approach and the if this then that and the like kind of frameworks?
Yes, thank you, Francois, for the question. I know the FTTT, but in fact, our approach wasn't based on it. It was interesting because it was the first time that someone compared the approach with this FTTT approach. So it's nice to see that there are some similarities. And I think our approach is more general, and we decided to use the BDD because it's also very well known as the FTTT, maybe even more because it's more general. And also we use the EOP to combine the specification of the exceptional scenario and how to specify a self-adaptive behavior. So I think the main idea is to put those very well-known techniques or strategies for modeling and programming together in a high-level domain-specific language. I think that's the main advantage compared to the FTTT. Thank you.
Thanks, Paulo. And I think Francois is so give it a thumbs up. All right. I actually have a question to Francois. Why is deserialization becoming a problem recently, especially when it comes to security? What's happening? What's wrong?
Well, the thing is, I mean, this is far from a new issue. It really, like the first Black Hat kind of talks go back to 2007, I think. So it's far from being new. It's just that I think more people's attention have been drawn to it recently, especially because it's very easy to gain like full control of a server, for example, or an infrastructure using this kind of attack. So for some reason, I think it was probably just a dark corner of languages that was known to a very few. And now that it's becoming more prominent, well, many people are looking into it and finding many variations. To be honest, I mean, I work at Oracle, and it's a constant stream of attacks month after month that we see. So yeah, it's very serious and very critical. That's the best answer I have to offer.
Okay, yeah. Seems there are a few dark corners around in the world that people are starting to dabble in, I guess, and deserialization seems to be one of the recent ones. Yeah.
Yeah.
So I see a few questions, I guess, being answered on the chat. So I just want to make sure that the folks who asked those questions have got their answers. I believe there is one more question, though, to Michael from Shihao about the optional garbage collection makes me think of the D programming language, which provides garbage collection as an optional feature in the compiler. Are you going to dive deeper to integrate this into Rust with the Rust team in the future? I guess like you started talking a bit more about some of the social aspect of accepting the idea of having garbage collection in the language, but maybe you can tell us a bit more about that.
Yeah, that's a good question. So I'm not that familiar with D. I was just reading up on it a little bit after you posted your question. So it seems like a neat, a neat point of comparison. So in particular, I'm interested in kind of what the reception has been in the D community. So, I think, one of the challenges that, right now what I have is a prototype. So it implements garbage collection for certain cases and not for others. We kind of went far enough to convince ourselves that it was going to work. But it's not, it's not something you could deploy. So, I think, we would want to kind of finish the implementation and make it general purpose and scalable. And then come to the Rust team with some, some numbers and say, look, here's how much it costs in terms of performance to use the garbage collector, and then sort of get some buy-in from some user communities. So and in fact, if anybody wants to work together on that, I think that would be really neat. I guess part of I think what's going on is if you go to somebody and say, how about you do all this work? It's like, no, how about you do all the work?
It becomes the hot potato problem, like everybody is throwing it to the other person.
Yeah. So I think they probably want more kind of mature implementation work from me before I come to them, with a concrete proposal. I could be wrong about that. That's just my guess.
If there are no other questions for now, I have a philosophical.
I don't see any further questions on the chat, so feel free to ask each other questions if you have any. Or generally speaking, anybody else who has any questions, please go ahead and ask them.
So yeah, I have a kind of philosophical question. I guess it's for Michael again, because you talked about the aspects that make people like a language more or not. I'm wondering if we should have some longitudinal study for when you're learning Rust, you're paying the price at the very beginning. Like it's hard from the start, which is the same with languages like Haskell, for example. That's the same kind of complaint that you hear. But then into industry at some point and you're waking up at 4 a.m. because your C system crashed and you have to debug it, then you might actually go back and say, shoot, I should have learned Rust in the first place because I wouldn't be in that situation. But we're not feeling this pain until much later. And I'm wondering how basically to bring the pain forward so that people can have a reasonable point of comparison and see, okay, is it worth learning Rust in this case? So any opinion on that?
Yeah, I think you're right. And I think, and I think people are going in that direction more and more. Right, 20 years ago, a lot of people felt like, dynamic languages were good enough and we don't really need the compiler to get in your way. And, that's just not the perspective most people have now, right? Unless you're a beginning programmer using Python. So, I think it's clear that that's the direction we're going, and that's why languages like Rust are taking off. On the other hand, one of the challenges that people have right now when they want to adopt Rust is, let's say a team is thinking about adopting Rust, right? And they're thinking, okay, it's a good idea, but it takes a while to learn Rust. So I want to be able to hire people who already know Rust, right? Because I don't want to have people on payroll who are not actually being productive yet. So good. So let's go hire some people who already know Rust. Oh, oops. Actually, there's not the Rust community is still limited, right? And so if you're thinking about adopting Rust for a project, even if it's exactly the right language, the learnability is a little bit of a problem, right? Because you don't have people who already know it, maybe easily accessible in your job, in your labor market. And maybe it's too hard to train people up. And so maybe you think, well, I'll just use C++. And, yeah, there are going to be some bugs, but we know how to fix those. And, probably at least from my perspective, that's the wrong answer, right? The right answer is, we should make the adoption curve easier so that people can get on board with Rust faster. So, my vision is people get started with Rust faster, but the code they write is maybe not as efficient, right? And so when somebody new joins the team, maybe you don't put them on the high performance component of the system. Maybe you put them on something that's a little bit less performance sensitive while they learn kind of the basics. Or maybe you're just starting a team, right? You're starting a new project, and you're trying to decide what to do, and somebody says, "Hey, this Rust thing sounds cool. Let's give it a try," right? And it's a new project, so performance isn't critical yet, right? So maybe you can get pretty far without having to learn the hard parts of Rust by using this garbage collector. And maybe eventually, yeah, you are going to have to convert parts of it to stop using the garbage collector. On the other hand, I've talked to people who said basically, look, I used to use Java, and Java was great until I had a performance problem. And when I had a performance problem that involved the garbage collector, I was completely stuck. I mean, there was nothing I could do to fix it, right? The only thing I could do to fix it was rewrite the whole thing in C++, right? And so now those people will never use Java again because they've been burned, right? It's like they've learned their lesson. Now they're not going to use Java. And now they have this, this religion like garbage collectors are bad. And, I get it. If you're, if your view is you can either use the garbage collector or not use the garbage collector, and those are your choices, and you've been burned by the garbage collector, you're probably not going to do that again, right? Whereas if we say, look, it's true that the garbage collector has some performance implications, but don't worry, you can stop using the garbage collector without rewriting your whole program, right? You can rewrite just the parts of the program that you want to remove garbage collection from. And actually, it's not a complete rewrite from Java to C++. You're changing which library you're using to do your allocation, right? You're maybe making small changes to how you're dereferencing your objects. So it's a much more gradual approach. And maybe we get a lot more people using Rust that way, right? And maybe a lot of those people just never encountered the performance problems. Garbage collection was good enough, and they just never need to switch to the ownership-based approach. I think one thing that was interesting about this work, when we did the experiment, we were worried that what we would find was people would be able to avoid learning ownership as a result of using the garbage collector. And then they would get to the last part of the study and be totally lost because they hadn't really learned key aspects of ownership, which are really central to Rust. But what we actually found was, in order to even get started using the garbage collector, you actually had to understand ownership pretty well, right? The thing the garbage collector helps with is multiple references to mutable data, cases where you would need interior mutability. And so we're pushing the learning curve back, but only kind of at the high end for the really tricky things. So I think there's an interesting question, a follow-up question, what can we do to make the learning curve shallower earlier so people can start it even faster?
Well, I think to some extent, one of the arguments that Rust folks had was the unsafe, like basically open up to C code, and so then you could gradually introduce more and more Rust in your code base. I didn't see that happening. I'm not in the Rust community, to be honest.
Yeah, I don't think they really advocate for that. I think what they advocate for is do it the Rusty way. The thing that's a little bit misleading about unsafe blocks that I didn't realize until I started using them a little bit. I mean, I needed to because I was writing a garbage collector, right? The thing about unsafe blocks is they actually don't let you violate arbitrary Rust rules, right? So, like for example, if you you want to mutate, you want an additional mutable reference to an object, right? You want to have two mutable references to an object. You can't just do that just because it's in an unsafe block, right? You get the same compiler error you would have gotten otherwise. Unsafe blocks let you do a couple of things. The main thing they let you do is dereference raw pointers. So if you switch over to using raw pointers, then you can only dereference them inside unsafe blocks. But if you're inside an unsafe block and you use traditional Rust references, that's not a get out of jail free card.
I don't see any further questions in the chat. Anybody has any further questions or other points that they would like to add to the discussion? Well, if not, I would give you back 7 minutes of this session time. And let's thank all our speakers again. Thank you very much. And let's thank our audience again for being here. I just want to point out one more thing before we go. If you would like to stick around during the virtual aspect of the conference, you can go to the Socialize tab on the left-hand side on your screen. This acts more like a coffee break, kind of like get-together area, so you can talk further there. You can have more questions, more time for discussion. And thanks to all of you. And I wish you the best of the rest of your evenings, mornings, afternoons, wherever you are in the world. Thank you, folks. Bye for now.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.